Okay, hello everybody, what's going on? My name is Mohammed, welcome to another video. In this video, I'm going to teach you how to solve for this integral. So we're given here the integral of the natural logarithm of tangent of x divided by 1 plus cosine 2x all raised to the power 2 dx. Okay, so how can we solve for this integral? Now we can notice, okay, that inside the natural logarithm there's a tangent of x. Okay, so if we can find a way that if we, for example, let the tangent of x equals u by using a simple u substitution, then we need its derivative. And we can notice here that the denominator, which is 1 plus cosine twice x, now it's basically the one can be rewritten as sine squared plus cosine squared, and the cosine 2x, which is cosine twice the angle of x, okay, can be rewritten as cosine squared minus sine squared. So basically the sine squared and the minus sine squared would cancel each other out, and we're going to be left out with twice cosine x, and that is going to be raised to the power 2, so that's going to give us 4 cosine to the power 4 actually in the denominator, which can be taken to the numerator to become a secant. Okay, I mean, we can get secant squared, which is the derivative of the tangent of x, and the remaining secant squared can be rewritten in terms of a tangent. Okay, so basically we can write everything in terms of a tangent of x at that. So that's what we're gonna do here, okay? So first of all, note that 1 plus cosine twice x is equal to cosine squared of x plus sine squared of x minus, cosine squared of x minus sine squared of x. So the first one, this part here is basically the 1 and is equal to 1, and this part here is equal to cosine twice x. So what we can notice here is that we can notice that this it's gonna get cancelled with this one here, and we're gonna be left out with twice the cosine squared. So that's gonna give us 2 cosine squared of x. And then we're gonna be taking this back here, okay? So let's do that, okay? Okay, so the integral I becomes equal to the integral of the natural logarithm of tangent of x divided by twice cosine squared of x all raised to the power 2, and we have dx here. Now, if we can let, of course, this can be rewritten as, again, the natural logarithm of tangent of x divided by 4 cosine to the power 4 of x dx, which also can be rewritten as the natural logarithm of tangent of x, and we can of course take the 1/4 outside the integral as a factor, so it's a constant factor, okay, and we're going to be left out with cosine 1 over cosine to the power 4, which can be rewritten as secant squared of x dx. I have split it into 2 secant squared because I'm gonna now go ahead and let tangent of x equals u, and that's gonna give us whose derivative is secant squared. So secant squared dx is gonna be the derivative, and the other secant squared can be expressed in terms of tangent of x. Okay, so let's do that. So let the tangent of x equals u, and that gives us that, let's differentiate both sides. Secant squared of x dx is going to give us du here. And also we need secant squared to express secant squared. Secant squared can be expressed as 1 plus tangent squared of x, which can be rewritten as 1 plus u squared. So let's do that, okay? Okay, so the integral now becomes 1 over 4, the integral of, the integral of the natural logarithm of u, and of course secant squared, let me use some colors here. Okay, the secant squared dx can be, is basically the du part, okay? Okay, and this part here can be, this part here can be rewritten, what's going on? This part here can be rewritten as 1 plus u squared. Okay, so we have du here, and let me write the 1 plus u up in the front. Okay, so 1 plus u squared. Now, when we see a natural logarithm multiplied by a polynomial, one of the first ideas that come to mind is basically integration by parts. Okay, so that's what we're gonna do here. Okay, we're gonna assume that this is the differentiable part. Okay, let's call that w, and the rest is basically with the du is the dv part. Okay, so let w equals to the natural logarithm of u, okay, and that gives us the derivative dw equals which is du divided by u, and the dv part is going to be 1 plus u squared multiplied by du, and the integral of that is going to give us u plus u cubed divided by 3. And of course we need to multiply this by this and then minus the integral of this times this, okay? And I will put a negative integral sign so that we remember. And I usually put that in a box so that things are organized and straightforward. But one of the things, okay, that we need to remember here is not to forget about the constant 1/4 that we took outside the integral. Okay, so that has to be multiplied with everything that we do here now. Okay, so that's what we're gonna do right now. Okay, so the integral I is gonna become what? 1/4, and then I need to multiply the u plus u cubed divided by 3. Okay, we need to multiply that by the natural logarithm of u minus 1/4, of course, because 1/4 is multiplied with both parts. Okay, the integral of, now if we multiply u plus u cubed over 3 multiplied by 1 over u, and we have the negative sign outside, then we're going to be left out with 1 plus u squared divided by 3 du. Okay, so the first part does not change at all, so we have 1/4 here, u plus u cubed divided by 3, the natural logarithm of u, and that's going to give us u divided by 4 minus u cubed divided by 3 times 4, which is 9 times 4, which is 36, of course, plus c. And basically now we need to substitute the tangent of x instead of u to get our final answer. So the final answer is going to be what? 1 over 4, the tangent of x, of course, plus the tangent of x cubed, tangent cubed of x divided by 3 multiplied by the natural logarithm of course, tangent of x, okay, minus the tangent of x divided by 4 and minus the tangent cube of x divided by 36 plus c, and that is basically the final answer to this problem. Okay, well, if you like this video, hit like, and if this is your first time here and you want to know more about brain teasers, riddles, logic puzzles, viral math problems, and all types of mathematics related stuff, then start now by subscribing to the channel and clicking the bell so you don't miss anything in the future. Thank you for watching and see you in another video. Thank you.